I promised you, so those of you who are impressed with Atlas can and should be impressed by it. And just so that you know, it's been a big community effort to build it, but Chris has been the leading chief architect. So he's not just presenting, but he's actually the inventor of all that cool cohort definition stuff that you had, which is pretty awesome. Yeah, clap for Chris. Clap for Chris. One of the things that quickly came out of all of the work we've been doing to try to think about cohort definitions is a recognition of the challenge that's represented by the fact that the phenotype that we want to define is an idea that's in our heads. And usually the way we express ideas in our heads, at least for some of us, is through words. We have words that describe our ideas. Some of us, like Chris, might think in terms of Java words, or I might think in terms of SQL, but most of us actually might think in just plain English sentences. And in particular, the way that we express cohorts more times than not is through words, whether those be through peer review publications or even through protocols where we have to just describe the inclusion criteria of studies in words. And so it was a really remarkable insight, and that's resulted in a pretty transformative innovation that Chunhua and her lab at Columbia University started, was to say, well, if everybody's using words to describe cohort definitions, why don't we just take those words and turn those directly into operational definitions of cohorts, just in the same way that Chris has built a tremendous UI to do that. So what Kong's going to walk you through is Criteria2Query, which is the latest OHDSI tool that's been released and is available for you all to use, and has been published in Jamia with some pretty impressive results. Kong's going to walk through the demo so that you guys can see it, and then we're going to immediately transition right into that, into an exercise so that you guys will all get the experience of playing with both Atlas and Criteria2Query. So with that, Kong,
okay.
All yours.
Can everyone hear me? All right. Okay, thank you, Patrick. He already told most of my presentations. All right, so I'm going to present this Criteria2Query, right? And first, nothing to disclose. And for the outline, basically, I'm going to give a very brief introduction about what is Criteria2Query and why we need it, which already finished by Patrick. And then I'm going to go through the Criteria2Query using exactly the same trial conducted by Chris in the morning. And then I'm going to take some questions. And then after question, I'm going to give you some instruction how are we going to conduct those exercises. I'm going to show you, we probably want to form up some teams or whatever. I'll go talk about this later. So let's think about, we have two people here, all right? Left one is probably a programmer. Let's call him Alex, okay? He's Alex. And the right one, ask questions to Alex. We have a lot of Asian here, okay? I made a name for this right one. I call him Dr. Park, okay? We have, how many Dr. Parks we have here? All right. So now Dr. Park asked a question. Hi, Alex. Could you help me query some patients? Alex said, sure. Here's Dr. Park. So how many patients do we have? Type 1 diabetes? And Alex starts thinking, type 1 diabetes, but we are using ICD-9 codes. What is ICD-9 codes for type 1 diabetes? Okay, do some search and return the results. 5 minutes later, another question from Dr. Park. So how many patients took insulin for at least 1 year after the diagnosis? Again, start thinking. All right, do the query, return the results. Okay, again, another question. Another probably just an email. And Alex start thinking again. And Google or probably whatever, try to return the results. And finally, Dr. Park said, could you send your query to other sites? Let's see their results. Can we do that? Alex starts thinking, no, we cannot do that. We are in different database. Database schema, database model is different, right? We cannot do that. All right, end of the conversation. So Alex starts thinking, we cannot do anything. What should we do? So that's why we are here, right? Odyssey. So how many of you are Dr. Parks? I don't mean real Dr. Parks. So how many of you are?
A couple Dr. Parks.
So Dr. Parks, who ask those questions in pure English or in Korean? All right. How many of you are Alex, who did program, do those search? Okay. So Dr. Park, you are lucky. You have your own Alex, and be nice to Alex next time. And Alex, don't feel sorry for yourself because you are here today, right? So you are here. We're going to give you some solution to save yourself. So as we can see, there's still a long way from clinician or investigator from cohort definition. You need to know how to write SQL. You need to know the data model of the EHR so you can create a cohort. So here comes Atlas. Thank God we have Atlas. Beautiful. In Atlas, you just need to click, right? Click a lot of things. You don't need to know how to write a SQL language. You just need to click, or drag, or typing. All right, so you get the Atlas, which can transfer your clicking to SQL language or your cohort definition, and this is shareable, which is good, but still a lot of clicking, and Doc Park still starts thinking, I get my Alex. I would prefer just send an email to my Alex. Okay, Alex think, all right, I'm a programmer, I'm going to save myself. So that's what Alex created. Criteria2Query, basically he created this Criteria2Query to translate this free text, basically an email, right? Or whatever, eligibility criteria to a database query. So that's how Criteria2Query works. It will take a free text as input and then translate it into a JSON format, as we just saw in the morning's demo. On the Atlas, there's a JSON format which is shareable across different Atlas instances. You can using the JSON to create your own cohort. So that's Criteria2Query did, and then within the Atlas, you can share your cohort definition, you can execute SQL, you can do everything. All right. So here's a modularized pipeline for Criteria2Query. I call it C2Q, just for easy. All right. So C2Q will take a bunch of eligibility criteria in free text format, just like what you see in the ct.gov. There's a lot of free text, basically writing, freestyle writing. And then there's a one section is information extraction, trying to identify meaningful, useful informations in this free text format. And then I'm going to just show a snapshot of eligibility of this C2Q. So as you can see, you're going to take two boxes. There's another which is initial event. So for these two boxes, basically, you can type whatever you want in inclusion criteria and also exclusion criteria. You type those things, and in the backend of Criteria2Query, it will calculate automatically using some machine learning models, do the prediction to highlight those clinical entities. For example, the first one, diagnose of, let's say there's an initial event, diagnose of AD, okay? So Criteria2Query is smart enough to identify this AD is a condition, all right? So it will highlight this AD, which is also predict a domain for it. If you remember in the morning, we have to add those different criteria, different domain, right, for of criteria. Some of them belong to conditions, some of them are demographics. For example, here, age is a demographic. And we also want to know, the value, the attribute of the age. So the Criteria2Query will try to identify this age, which is from 50 to 85 years, trying to identify this, relationship, extract this relationship within the free text. And after that, we want to do some entity normalization. When I say entity normalization, anyone remember we are using concept set in the morning, right? You didn't really create any concept set. We are using concept set created by Patrick. But in real world, you have to create your concept set. So a concept set basically in OHDSI community means a collection of different concept IDs, standard concept IDs. So for this part, if this AD is a condition, but it's written in a free text, machine should be able to know, okay, which concept ID we are going to use for this AD, or which concept set I'm going to create for this AD. So if there's some concept set already exists for AD, you can reuse it. It's easy. But if there are none, then you have to create this AD based on string match to search the concept, standard concepts in the OMAP vocabulary. So that's how it works for the entity normalization. And finally, you get everything. You generate the JSON format as we showed in the morning. You can load this JSON in the Atlas. Just review your query and do some necessary editing, and then you can execute and share your cohort definition. So that's it. See, you generate this JSON, which is exactly the same. Go ahead, question?
Yeah, just a quick question. So in your example, you have AD, so that could be autoimmune disease, Alzheimer's disease.
Yes, great question. So the question is, here I show the example AD, which is a condition, but how does the machine know this AD should belong to autoimmune disease or Alzheimer's disease? In this case, no way, we don't know. So machine will pre-populate different concept sets. You are going to select one, and you do have to go into the concept set, see machine select the correct concept ID for you. That's very important. Sometimes we cannot just rely on machine or trust machine. Machine made mistakes, definitely. Go ahead, question?
Concepts are uniform across different institutions, or is it specific to your lab?
Okay, so that's a good question. So I think question is concept set is uniform is uniform across different institutions. I would say no. So different institutions try to create their own concept set. But one idea of OHDSI community, I think, is we're going to share this concept set. So if someone already creates some concept set, why don't we bother to create another concept set? We probably should just reuse others' created concept set, which can save us a bunch of time. I think that's, do I explain this correctly?
So for those who are just getting familiar with the OMAP Common Data Model, all concepts are unique and consistent everywhere in the world. It's the grouping of the concepts into a concept set, which is an analytic activity that has to be performed per study. And I totally agree with what Kang's saying. We really should be trying to work as a community to also share those groupings as we create them, much in the same way that we are already sharing a single unified vocabulary of unique concepts that everyone in the world's using. We should also get to the point where we're sharing concept sets. But there's logical reasons why two researchers might choose consciously to put different concepts in a concept set and but possibly label it similarly. And there may be reasons why for a given clinical idea, two rational people could make different choices about what they want in and out of that idea. But the building blocks are all unique and consistent everywhere in the entire OHDSI community.
Sometimes it's really hard to tell the difference between and or. Or even the eligibility criteria is written in natural language. How does C2Q handle those kinds?
So technically, in C2Q, we are using Stanford published dependency prediction to predict those conjunctions relation between two tokens, and then using those conjunction to formulate the logic, the query logic, like and or relationship. But obviously, machine again will make mistakes. So that's why we are going to load the JSON into Atlas to review the query, try to, if there is something you want to correct, you correct it.
Can the system handle bullets? If there are some criteria that are stipulated in different
Oh, yes. So that's basically something we can handle using, sentence segmentation. We can identify, individual sentences, but it's extremely difficult to notice what is the relationship among those bullets. That's, a big question. Because sometimes even human beings don't understand, should we use in or for those, or should we use and? So again, that's hi, question?
Just as a presentation, may I ask which data set do you use to evaluate your model? How good it is? How they calculate accuracy? I mean, like when you extract concepts and relationships?
I'm sorry, can you speak your question again? Are you going to talk about the evaluation for what?
For your model.
How did we train Criteria2Query?
Not to train. How do you evaluate? You have a model, and you need to have some kind of annotated data, just what you expect.
Oh, okay.
And what your model.
So for example, this afternoon we are going to do two exercises, right? One, we are going to using Criteria2Query, and another is we are going to start from scratch using Atlas to create a cohort. And we are going to have two separate cohorts, right? And we'll have some golden standard, which is, we have expert like Patrick create a gold standard cohort, and you can compare, cohorts against another cohort.
But do you have any
Data
sets already labeled in this way?
Yeah, we do have. We do have different data sets available. For example, at Columbia we have our Columbia dataset EHR data, which is in ALMA format, so we can use to evaluate the results.
And I guess maybe if I'm understanding the question correctly, so part of what went into the team developing Criteria2Query was to actually be able to train the natural language processing to perform these tasks of extracting things out. And to do that, one of the things that Chunwa's team did was manually annotate an extraordinarily large set of studies that come from clinicaltrials.gov, where they actually annotated all sorts of inclusion and exclusion criteria from a lot of studies and used that corpus as the training ground to develop the model that we are now applying in this free text tool.
But is it available publicly?
Is what available?
Annotated data.
We are going to publish a dataset. I don't know whether Fabrizio's dataset already published. Fabrizio's not yet.
Towards, eventually we will make.
Eventually we're going to make it published. Okay. Any more questions?
I have one question, feasibility question.
Sure.
So you're parsing paragraphs. Is it feasible or possible to basically, instead of like the free text formatting thing that leads into the eligibility criteria representation, that you potentially could like show an image of a flow chart that would just basically plug in instead of starting from text or starting from the flow chart, that gives you the same sort of identification of things that then feeds into the second 2/3 of this process. Is it something that's feasible? I'm just sorry to detract, but
That's feasible, actually. I really
Yeah.
like that idea. We actually, when we designed this Criteria2Query, that's part of the initial plan. But due to a tight timeline, we kind of prioritize towards the lower priority than getting it working. But I agree with you. That will greatly increase the usability of the system. We should add that at some point down the road.
Are you able to work the other direction, and once you've got this well trained, to be able to process a larger literature to identify studies that may have difficulty in being reproduced because the definitions are poorly designed?
Yeah. Yeah, I agree. Totally agree.
I would encourage you to look up Chunwa Wang in PubMed, and you'll see a series of very impressive publications on this topic.
Yeah. Okay.
Actually, probably look for Wang and Ryan, because there's too many Wangs, but there's not very many Wangs and Ryans together.
Special combination, all right? Any more questions? All right. So we get, then I'm going to, all right, and that's the publication. We just published a paper on JMEA 2019, and Chi, who used to work at Columbia, should take the credit. And okay, he still work, yeah. And we have the code published in the GitHub under OHDSI repository. Okay, so if everyone's good, I'm dive into the demo. I'm still going to using the rally trial, which we showed in the morning as an example here. Okay, here we go. All right, so this is the URL for Criteria2Query. Just type odyssey.org/web/Criteria2Query, and you are going to landing in this view. So again, I'm just going to replicate the trials we just did in the morning, the demo, the rally trial, okay? So, can everyone see this? I will just zoom up. Oops, that's too big. Okay, so the initial event, as everyone remember here, is Warframe new users. I will just copy paste here. And inclusion criteria, that's the inclusion criteria we used in the morning. Some of them are quite complicated. And exclusion criteria we used. All right, any questions here? Are we good? Okay. So if we're good, we just click parse. Okay, so Criteria2Query will identify different clinical entities and their attributes here, using different colors to mean different domains. And then you just simply click generate query.
I don't think everybody understands how
to read all
those. I think it'd be useful to
okay.
take the time to go through it.
Okay, I'm going to go back to the main page. So the idea is quite easy. You just using this, writing language as you did. For example, here I have the Warframe new user as my initial event here. And I have those inclusion criteria, copy and paste it here. And I have my exclusion criteria, copy and paste it here.
And just to be clear, he's copying this off of a PowerPoint slide, but that's actually the text verbatim off of that clinicaltrials.gov page.
Mm-hmm. So I just click the parse. And here's the parsing result for Criteria2Query. So I will make more clarification here. So for example, the initial event here should be a drug. It's a drug exposure, right? As we remember in the morning's demo, it's a drug exposure. And this is a warfarin. So, but we haven't created any concept for this warfarin yet. So in this page, we just show, okay, this is related to drug exposure. And there's a string named warfarin, it's about this initial event in terms of drug exposure. And then this line is the inclusion criteria. So the first inclusion criteria is age, which is a demographic, right? And it should be age larger and equal to 18. And this is the attribute associated with this demographic, this criteria. Okay? And here, obviously, there's a weird mistake. Probably did a wrong prediction, because history is the observation, but history is so broad. Do you want to really using history as an observation criteria? Right? That's kind of weird, but
actually, I will say that they are talking about recording history of conditions as an observation domain.
So
with a value as concept of what you're identifying there. So it's kind of correct.
So, but here, okay. So it's like we should add a criteria domain as history criteria. But actually, it's much easier to interpret like a prior condition with prior condition of non-valvular atrial fibrillation, right? So, and this is the condition identified for the second criteria. So you are going to add a, condition occurrence criteria for this one. And the third is quite complicated here, a bunch of conditions and 2 demographics. We are going to show later in the Atlas page, see how it works. And also exclusion criteria. So different things, disabling stroke, which they think it should be a condition. Yeah, it is a condition, but can we find this condition in our concept set? We have to ask this question again. It turns out we probably don't have this billing code as disabling condition, okay? And this is the temporal value associated with this. So if you remember in the morning, we have those weird, a lot of time windows to be specified. So that's also a temporal attribute for a criteria. And here, Criteria2Query will predict this temporal attribute for this specific criteria. And again, here's the measurement. Measurement is another criteria, and measurement should have some attribute, which is numeric values. And again, we have this value as a attribute for this criteria, this measurement criteria. All right, any questions for this page? If we get, then...
Hold on. So I just want to make sure everybody understands this, because I think Kong and Chunhua and the team are world's experts in natural language processing, so take for granted how freaking amazing this is. So we just pasted free text, and the algorithm automatically did all of this detection and created these criteria and pulled out these pieces. And the next step is going to be, now that you have these pieces, can we put them together into an Atlas cohort? But the fact that it's actually doing all of this named entity recognition at this level of fidelity matched to the OMOP common data model, so we know all the domains, at least from my perspective, is really an important innovation that opens the door to a lot of things that we can do now that we have this capability. So since we're going to flip over to just showing what happens, I'd encourage, if anybody has any questions about this or doesn't understand it, this is a good time to ask.
All right. So just simply click it, generate query. It will generate this JSON, which you can share across different institutions, across different Atlas instances. I'm going to simply click this check on Atlas, which means we are going to load this JSON into Atlas cohort. Yeah, so for the Atlas part, actually is the same as we talked, but we are going to create a template, Atlas template. We are trying to do most part of the Atlas for you, but you still have to dive into the Atlas to look at what you created.
Right, between doing it manually and using this, what is the percentage of doing it manually?
Could you speak up?
Could you
No, I just wanted to know, what's the difference between manually doing it, like we put it on the information on the Atlas, and now essentially for us.
Well, he managed to do in 30 seconds. Well, I
Exactly.
spent
I'm very
45
impressed.
minutes.
I don't even have to bother with all those things, but how close it is to doing it manually is what I want to know.
Yeah, I'll say that the motivation of this exercise that we're going to be doing this afternoon is to try to understand. So there's huge efficiencies that can be gained by doing this, but there's also the challenge that it's not always going to get the answer right.
Yes, so I'm going to show it right now.
Part of the reason we're doing an evaluation with you all as our test subjects is to try to understand, do we think the value of the efficiency is worth the cost of the review and revision? I can say, like this example we just did, like we only had 5 or 6 criteria. One might say, well, it's only 5 or 6 criteria. What's the big deal? It shouldn't take that long to do it manually. But Rupa's in the class here. She leads our clinical trial feasibility group at Janssen. And the typical trial we're doing has 30 or 40 criteria. And suddenly you start multiplying that it's not seconds or minutes, but it's hours to enter in these criteria. So you could imagine that if you're doing dozens or hundreds of trials, that adds up a lot. And if we could have a tool like this that could get pretty good, you're really talking about improving the reliability and efficiency of the work you're doing.
Right. So we just loaded this into Atlas page, and the Criteria2Query will automatically create a cohort with named C2Q, blah, blah. something like that. And we get this cohort created automatically by Criteria2Query in Atlas. And then there's a cohort entry event, which is same. But here, I want to point out that this C2Q warfarin, this concept set is created automatically by Criteria2Query. So remember, in the morning, Chris has to import concept set, which has been pre-populated by Patrick. So here, Criteria2Query will generate this concept set directly for you. But also, very importantly, again, this machine product might be not accurate enough. So you might want to dive into this, this thing to look at what exactly created by, Criteria2Query in this case. So turns out actually this case is quite simple. So both Chris concept set and Criteria2Query set generate the same thing. If you don't believe, I can show you. You can compare what is imported by. You can also import. So import concept set here. Let's search created by warfarin. Okay, so this one is used in the morning's demo, which is manually created. Okay, so if you dive into this, actually it's the same because this one's quite simple. So Criteria2Query is managed to do this automatically for you. But if you don't like this, you can simply change it, import a concept set, just like Chris did in the morning. All right?
But the number of concepts are different from the previous lecture. So in this case, less than 500 included concept number on the text.
Oh, sorry. I should have mentioned this. So this concept set here actually means the concept set used in this cohort definition. But I'm talking specifically about one concept set related to the warfarin. So it's showing here. So one concept set, warfarin.
I think the number of automatically generated concepts are different from in other cases, not automatically generated conditions.
Can you repeat?
So when Criteria2Query ran, it identified how many concept sets were needed.
Oh yeah,
And that's
in
a
total will be different.
number than the number that
Right.
we manually decided.
Of course.
Number 35, CTQ history,
Yeah.
was not something we needed because we knew better, but the parsing identified it as
Yeah, but here I'm talking specifically this one, right? Right, so it's talking about this one. Yeah, if you don't like this, you can modify this here. So basically exclude whatever you don't like. Right? So again, as I mentioned, this concept set created by machine, yes, of course, it will be different from what is created by human. It can be different. So if you trust human better, you think we already have some concept available, why not just using human concept, right? So then you basically simply import concept set, which already created by human. But remember, in most of case, you don't have this concept set available. What you should do, maybe it's a good idea to ask a machine to create some concept set for you first, and then you dive into that concept set, see okay which kind of things you want to remove, and maybe you want to add something new into this concept set. So that's the idea. Ask a machine to create something, but you still want to dive into it. Go ahead.
Might have already touched upon this. The concepts that are returned, are those always only going to be standard concepts, or could it return something that's maybe higher in the hierarchy? If I said like diabetes, would it make a decision on type 1 and type 2?
So in this case, no. I have to say that the reason is this kind of things, the concept search is string-based search, so it will create different concept sets.
You're asking if the concept sets return are often standard concepts, right? So in our algorithm design,
I think the question is about if the text specify diabetes, are we going to predict the type 1 diabetes or just diabetes concept? Is that your question? Or my honesty?
I guess, yeah, in other words, what would be return? So if we said, among diabetes patients, would it return patients that have diagnoses of
type 1 diabetes and type 2 diabetes?
type 2 diabetes or either diabetes?
So in this case, if you specify diabetes, yes, it will return both actually. Because it's based on string match. So it will return both. But if you specify type 2 diabetes, it will return type 2 diabetes specifically. But there are some cases which is very difficult, which, for example, conditions associated with something. So if there's some concept actually is defined like that, conditions associated with that, then we are able to identify these things. So for example, condition associated with bleeding, right? So if there's a concept ID, defined in that way, then we are able to identify this. But if there's no concept actually is defined like that, then that's caused a problem. We have to, in most of cases, you have to specify this. What is the condition for this one? Does that answer your questions?
We have a lot of vague, as you don't say, we have a lot of vague criteria.
Yeah, especially in the ct.gov, like in the morning, we look at what is the disabling stroke, right? Turns out we don't have this code for disabling stroke. So we have to, put our own interpretation for this disabling stroke. So here, just like usual, you can specify this as the earliest event. And we're going to have 1 year prior observation. And here basically is something created which is similar to the earliest one. So you don't necessarily need this, so you can just remove this. And let's look at the inclusion criteria here. So one thing, Criteria2Query automatically transfer those inclusion criteria to inclusion criteria automatically. So for example, in your exclusion criteria, you are set no anemia, right? Exclusion criteria actually is anemia. That's something you want to exclude. So we do identify, okay, you have to have all of the following criteria, which is with exactly 0 occurrence, which is basically it's exclude anemia. So let's look at each criteria. The first one, age, which is quite simple. So made a good job. We don't need to update anything. Look at the second. So again, this kind of weird because the history they identified as an observation, but actually it means some prior condition, prior existing condition of this atrial fibrillation. So you can delete this one, and unfortunately for the temporal part, it made a mistake because it thinks the history is an observation. So you want to change this between, let's say, prior, then that's all days before, and 0 days after the index date. And again, you can dive into this concept set, see, okay, whether this is the correct one. Maybe it's good. I will leave it here. Oops. Okay, go back to the definition. Okay, then this one comes the very difficult one. If we remember in the morning, a lot of logic, a lot of parentheses. So let's look at how Criteria2Query did. Actually, a lot of mistakes, but one good thing is those small modules can be reused in Atlas. So what I'm going to do is I'm going to keep these small modules, so these small blocks here, but I'm going to create those parentheses. So I'm going to add some groups. Basically, I add those groups to, combine different criteria together. Okay, so first is a lot of or. So stroke. Let's look at the stroke. Okay, there's a stroke. If you don't like this, in this case, we already have, stroke concept defining our concept set, you can just search stroke. Here, and we're going to using the pre-populated concept set, just like what we did in the morning. And another one, we have stroke, and we have, let's say, what is next? Next should be left ventricular dysfunction, okay? Again, this one, I'm not going to change all the concept set here, because if you think, okay, I'm going to using pre-populated concept set, you can just using pre-populated concept set based on the same idea, but if you cannot find it, then you just dive in, look at how the machine works on this part. Again, what is next one? So should be 2R and or age 75. Okay, so here is a very weird part. Criteria made a mistake here, so it should be or 75. So we have three or defined, and another or should be a parenthesis, okay? So basically I treat each group as a parenthesis. We have this another or here. And within this, we need age larger than, so within this is an and relationship. So we're going to, for and, we're going to have or within this parenthesis. So if you look at this group, you just treat it as a parenthesis. So we are going to drag this age larger or equal to 65 into this parenthesis.
It's a very narrow window. You'll have to drag again. But just kind of wade it over it until you see it expand.
Okay.
I think it'll be okay. Sorry, sir. Yeah, sorry. We will look into that. But if you want, you can just add the demographic directly.
Yeah.
And then drag it, and that'll give you more room to move in. So just add demographic here, and then you will have room to drag it from above.
Okay.
Let's try that.
Smart.
Yeah, we'll see.
Okay. Create some extra space.
Yeah, let's see. Try below it. Yeah, maybe it's also resolution. Sorry. One last try.
Okay. All right. Yeah. Okay. Again, there's another parenthesis, okay? After the age larger than or equal to 65, we're going to create another parenthesis, which is add group. Okay, you add group here, and then you are going to drag other things here, which diabetes. Oh. No. Oh, yeah, yes. Okay. And coronary artery disease, I will drag it.
A little lower. Try right above the button, like lower. Let's see. Yeah, that's not right.
Let's do the cheek again. Hypertension. Make sure we are put it in with the correct parenthesis, okay? Okay. Do work. No. All right.
Zoom out to 100% and then the
Zoom out to 100%.
Magnifying glass in the address bar, you can change that zoom. I think it's the zoom in is messing with the detection of the thing. Just reset that.
Reset?
Yeah, okay.
Oh, okay.
Perhaps that'll help better.
Okay. So. It works? No. All right. Anyway, that's the idea. So you can drag everything. Actually, I tried this on my laptop. It works perfect. So I don't know why with the presentation doesn't work. Okay. But just remember here we do have to make some corrections. If you look at details here, it is required something prior, so it should be after the index date, before the index date. So I will put 0. Okay, and for the exclusion, again, so here's the situation I mentioned. So Criteria2Query think there's a specific code related to, disabling stroke. So let's see what it is. So actually, it's just a stroke. Okay, he thinks the stroke is a disabling stroke, which in our definition actually is not. We have to, design our own rules to implement this. So I will say in this case, actually, if we can have some concept set or some certain definition which can be reused in this case, then Criteria2Query can definitely just reuse whatever designed by human to interpret this disabling stroke. But unfortunately, in this case, if you only say disabling stroke, it doesn't understand this right now. And obviously, even in the morning, we still have some troubles to understand what is disabling stroke. We have to design those visits, and we still have questions about those visits. Yeah. But if you can specify this in pure language, probably we can try that in pure language. Just specify, okay, we require a disabling stroke and with a certain visit, inpatient visit. It probably gonna work. Okay, so another exclusion criteria, this is an exclusion criteria. So as you can see, we have EXC here, which means it is an exclusion criteria here, all right? So for exclusion criteria, we want to have all of those with exactly 0 occurrence. So, and here is previous 90 days. So Criteria2Query do identify this 90 days before and 0 days after. For this one, anemia, and automatically create an anemia concept set. And also hemoglobin. Here it created a value for this one. Go ahead, question?
Yeah, so I just want to clarify, this morning Patrick already said in Atlas, everything is an inclusion criteria. So here, what we see, inclusion, exclusion criteria, is just pure language.
Yeah, just pure language.
From the raw text from clinicaltrials.gov or clinical summary, because all the protocols, they like to have a section for inclusion criteria, a section for exclusion criteria. Let's just carry forward from the text. But I want everybody to remember, like in Atlas, everything is treated as an
Inclusion criteria, yes. So basically, we translate this pure language defined exclusion criteria into an inclusion criteria in Atlas. That's what we did here. But the text basically is the text from the pure written text. So that's how it works. And also the value, but we don't have the Criteria2Query missed the unit for this value. So you probably want to add the unit for this value. So you can add a unit criteria. In this case,
The only issue there is that we're showing standard and non-standard.
yes.
So uncheck that one and maybe sort by standard type.
Oops.
And then,
Okay.
there you go.
So you have to pick up the
Capital L, you want grams per liter.
this one. Okay, and just add it. And of course, if you have other interpretation of unit value unit combination, then that's going to cause a lot of trouble. So hopefully we can fix this with some more sophisticated solutions. Yeah, so that's it. And of course, another thing. For example, here 100 times 109. What is this? Anyone know?
I know, but I cheated.
I guess this is a typo.
No, it's 10 to the 9.
Yeah, I guess 10 to the 9, right? But
And 100 times 10 to the 9, so they could have just said 10 to the 11.
so unfortunately, machine doesn't understand this. That's too sophisticated. It understands this like 2 values. Yeah. Okay. So As usual, you have to dive into the atlas and do some corrections. Any questions for now? Oh, yeah. So you don't necessarily need an end date, right? So because for measurements, usually it's only one time point. So it depends on different, for some drug error, you will have, or visit type, you will have to start and end. But for drug measurement, it's only one time point. So it's not necessary to have this, but I think it's also fine if you have this, because everything's all and all. Basically, it doesn't make any sense.
And in fact, when we translate that to SQL, we see an all before all and all.
Yeah.
It's a meaningless statement.
Yes, it's a meaningless, right. Yeah.
The problem that with this approach is that I think even though a patient's strong site count is less than 10 to the 9 per liter, he or she is not necessarily diagnosed as thrombocytopenia. So I think we should approach that instead of using condition but with measurement.
So here is an exclusion criteria. So remember,
True, but
so
thrombocytopenia is a condition.
right.
We have to diagnose
Mhm.
a patient with either
Right.
thrombocytopenia or not.
Right.
But that, even though that patient's thrombocyte count is platelet count is less than 10 to the 9,
Mhm.
he or she might not be diagnosed as having a thrombocytopenia.
Yes. So in this case, we are trying to exclude those potential patients who are not qualified. But of course, you can put your own opinion on this part. Again, it's based on your interpretation and your own design of this eligibility criteria.
Or you just define thrombocytopenia in this cohort definition. You just define like that. So thrombocytopenia you can define any number if you want. Yes, because it's not like a fixed one, right?
Or do you suggest that we change N to all? Because right now there's an N relation between diagnosis and measurement. How do you suggest?
Yeah, no. He said why you put thrombocytopenia the condition, not
Right.
just the value. But what I'm saying is thrombocytopenia, the definition is not fixed. You can define like 10 or
Or
yeah.
in this case, 100K. But
Mhm.
in other case, my suggestion is not to use condition for the domain,
Right.
but instead of using measurement or laboratory tests.
But are you suggesting just remove that condition?
So just remove this.
Yeah, right. It's
Yeah, that's what it
Yeah. Then.
the first condition, but just a kid percent.
Yeah. Then I mean, in that case, you have to write in your pre-tag, free tags. Just don't mention this condition.
No, I think that's the flexibility that Criteria2Query enable, because our principle is really human-computer collaboration. But we take the English text that includes the condition there, and we help you to translate that into code. But you have the freedom to say, I don't need a condition. You just click a button to delete that.
Mhm.
Oh, so
So if you don't want this, you just delete this. It's quite simple.
By the way, there's no one new, so it's gone.
I think Tony is trying to.
what the thing is that difficulty with natural language is that, the thing is, which is within the parentheses can be interpreted as either IE or having both.
Mhm.
So
Right.
that gives us some difficulty.
Agree.
Translating that
Agree.
is something that-
But that's something we human beings should fix first, because we are sometimes you put something in the parenthesis.
But I would interpret that as
Different people will have different interpretation. That's going to cause the trouble, and that's why we probably want to share this atlas generated cohort other than free text cohort.
And what Criteria2Query generated is not the end product. It's actually just help you to finish. Maybe our goal is to let it finish 80% or 90% of the work, and let you to push the last mile before you arrive at the perfect cohort. But
Yeah.
our goal is if we can help you to do majority
All right, any questions until now? I guess a lot. Okay, go ahead.
I'm wondering how the program generates the concept sets.
I'm sorry. Okay, so the question is about how program generate the concept sets, right? So in OMAP vocabulary, we have those standard concept IDs, and the concept set means a collection of concept IDs. So basically, we take a string, which is a clinical entity. We take the string, do the mapping, string-based mapping to all those concepts and their synonyms, and try to identify those concepts. But we also search the concept sets, which are already published in the atlas, which have the same string name, and we are going to using those concept sets.
So for diabetes, is it looking for
So
any concept that says the word diabetes, or like looking for the ancestor diabetes standard concept, and then all of the things?
So for this one, it's going to search the vocabulary and also concept sets published in this atlas instance. So both. Yeah, of course. So for the domain, it's always identified first, like a condition. We only search, concepts ID on this domain, this condition for diabetes.
But it's just doing a text map across all of the concepts.
Yeah. Yes, and also concept set names. Any other questions? Okay. What? Oh, okay. So another thing is you have your, Criteria2Query generated cohorts. So maybe the very beginning thing you want to do is you can, save it. You can copy it. There's a function in Atlas. You can copy it, the current concept, and copy it to create a copy of this concept. Then you can modify this concept, copy and modify this concept, this cohorts, and then you can update your cohorts in, within this copied cohort definition. And of course, you want to put your own name, a specific name. Make sure you can, find it back. Other than this weird, C2Q something, blah blah blah. It's hard to remember. You can put your own name to make it identifiable. All right. Any more questions? Go ahead. Misspelled themes. Again, so for misspelled themes, we using string-based match. So if it is highly matched with some certain streams, we're going to identify that stream. Go ahead.
Is the developer, are you all still planning on continuing to have the machine digest new lexicons and whatnot? Because I tried searching for some oncology terms and the concepts were very off. Like immunotherapy only picked up interferon. It didn't pick up like all the other PD-L1 agonists.
Definitely. So basically, the current version of Criteria2Query includes a hybrid concept extraction method. It combines rule-based and machine learning-based. But the machine learning was trained using 300 Alzheimer's trial, annotated Alzheimer's trial. And as Tom mentioned, we recently completed another 1,000 trials annotation that represents different disease domains. But we didn't get a chance to use that 1,000 trials annotated corpus to retrain the machine. Like the version has not incorporated those data. So hopefully, after we retrain everything in a larger new data set, the problem can be potentially addressed. But I agree with you. I'm collaborating with the cancer informatics researcher. We are looking at the cancer criteria. A lot of the cancer-specific terms, such as T1-4 breast cancer, these cannot be extracted. So these are things we still need to work on. As you understand, I think in academia we don't have a professional software development team, so these we have to go through this slow process based on the differences.
So another question?
Just to clarify, so you do not use regular expressions at all?
No. So wait. So I have to clarify this. As we mentioned, this is a hybrid methods. So part of it actually is related to regular expression, because we have to search the vocabulary. That's the part of it. But we are going to using machine learning to do the prediction, like tokenize each token or each a bunch of token belong to certain condition. It's like a entity recognition task in the natural language processing. But we also using regular expression to match something which we can find it in the vocabulary, in OHDSI vocabulary, try to identify it. So it's a hybrid method.
Do you envision expanding your hybrid method to use external NLP systems like Comprehend Medical?
Yeah. One thing is, I don't know how is the NLP designed, the method of NLP designed specifically for OMAP community. If we can, let's say in the future, we can identify those terms very accurately, which can be mapped to certain, OMAP vocabulary defined concept sets or concept ID, then this kind of technology definitely can be used in this software.
So compared to other NLP systems or other name entity recognition systems on the market, I would say this is one of the few that leverage the OMAP common data model,
Yeah.
map everything to OMAP common data model
Right.
concepts. Because a lot of people already done other name concept recognition work. Yes, I think that's kind of, and we actually did a time-based evaluation. More than 80% of time that Criteria2Query spend is on the concept mapping part. This is the most difficult part, because as earlier people mentioned, we have vague concepts, we have abbreviations, we have complex sentences, and all these can confuse the model behind Criteria2Query. So that's something we're still hoping that the larger annotated corpus can potentially address or mitigate the problem. So that's still ongoing research.
So like I mentioned before, there's one thing in the morning, we're just using pre-populated concept sets, and everyone probably take this for granted, which actually, it takes a lot of time to construct those concept sets. That's why we want to share this concept set, and that's why also it's very difficult for machine to get those concept sets.
Yeah, and we were
Question.
David and I just want to add that we were just looking at one concept. What's that? Yeah, it's a drug. And if you just enter that drug name itself without any context into Criteria2Query, it parses perfectly and recognizes the drug. But if you put it together with many other things in a very long sentence, we can parse other drug names, but that one gets left out. So this is kind of the things area we still need to improve upon.
Question.
When will these C2Q tools be the regular function of the atlas? Is there a plan?
So this tool actually is a plus-on for Atlas. It is, served actually in OHDSI, as you can see. So it can connect to any Atlas version. So you just need to change some configurations and connect to any, Atlas version. So it is, you can use it now, but still, even a very bad, model, you can use it because you dive into the Atlas, you change everything, you delete everything, and recreate everything, right? So it really depends on, one of the, important goal for this afternoon's exercise is we want to evaluate how much efficiency it can, we can get by using this tool.
But I'll be very specific. So the team, Chanwa's lab and Pongin have released this tool as an open source capability for OHDSI. It is available. We are hosting it as OHDSI as a resource for everybody, and we're teaching it today because we think it has value. And specifically, how I think about using it is I go to this website, I see how well it does, and then I decide whether or not there's some gain to be had in copying that over versus just doing it from scratch. And the exercise we're going to do is to actually try to quantify, is it better to use it or to not use it? And we're treating that as an open research question where we are quite encouraged and excited about this novel technology, but it needs to be quantified what the value is to gain, and that's why we'll be doing that together as a group.
Looks like there's a space where I can put into an NCT number directly.
Yes, you can.
It doesn't seem to be working properly. Is this just me or?
So one of the reasons is because let me go back to the criteria query. Okay. So one of the reasons is this trial specifically doesn't work. The reason is this is a very simple parsing function, and we are going to split into inclusion and exclusion criteria. But for this one, unfortunately, we didn't notice actually in the clinicaltrial.gov there's something like this. So we always think it should be like a inclusion and a space after this inclusion. But for I can try. So for the trials you are going to use in the exercise, we do have this function available. So let me just give you a very quick example.
So that's another thing, like clinicaltrials.gov, a lot of the typos and other.
And in clinicaltrial.gov, not everything is defined like inclusion criteria, exclusion criteria format. It's like something very weird, like I don't know. Yeah. So I can show you one example here. No, this Ryan's tutorial. So let's try this DCP.
I don't think you want to do this.
Okay.
Don't do that.
All right.
Use that example one that you got. Don't do that one.
Oh, okay.
That'll bias our experiment.
That's true. That's true. So I'm going to using anything. Can anyone provide some NCT ID? Any trial number?
I don't know clinicaltrial.gov trial numbers off the top of my head.
Oh, I can try the example.
Google like adaptable.
Wait. I think I do have the example. Okay, NCT.
0164 0837. 0164 0837.
Okay, yeah. So for this one, we can just fetch the inclusion and exclusion criteria, but we don't really look at all the trials in CT.gov, so we don't know what kind of other bugs they do have.
There are some trials with special characters.
Yeah. Yeah. So I will say the best idea is still you just copy paste and make sure this is the context you want to use for the trial, and then copy paste in the inclusion and exclusion criteria specifically. All right. Question?
Make this algorithm more smarter, you may need more annotated data. But making annotated data requires huge resources. But instead of that kind of annotation, if this tool is used as a regular tool of the Atlas, which of the function, the accuracy may not good. But if someone uses this tool, then he must correct that result into more accurate one. So the kind of the annotation activity can be used for that to improve your accuracy.
Very good suggestion.
Yes.
I hope. Yeah.
Yeah, that can provide a lot of annotation data for us. But before that, we need a lot of users.
We need crowdsourcing within the Odyssey community to accelerate the improvement of these systems.
You'll need a lot of consent.
Hmm?
You'll need a lot of consent from those users as well.
Oh yeah, to collect the users' behavior. Any more questions? Okay. So if we don't have any questions, we are going to dive into the exercise.
Yes, so we're going to break into exercises here. So Kong's just going to explain to you, just to be clear, what we're trying to do here is actually, our primary motivation is to teach you guys how to use Atlas and Criteria2Query, but we are trying to do this in the confines of running an experiment right now. So for all of you who will, you should have all received an email with a consent form that described what we're doing, and Kong's going to talk about it. And if anybody
you should have a consent form on your table right now.
Oh, and on your table, you've got a copy of a consent form. And if anybody really feels that they've got a concern and would not like to participate, that's totally fine, and you can just let us know. To be clear, what we're doing is this is research for us to try to improve how we are developing Atlas and Criteria2Query, and we're hoping to use your experience as a motivation for collecting the data necessary for us to continue to build and improve these tools. The exercise what we're going to do is we're going to have you guys have the opportunity to do 2 different cohorts. And we've picked studies for you so that you guys will get to experience ones. We picked studies that are good and important and clinically relevant questions, but are reasonable to do. And every group is going to get the opportunity to use both doing a cohort definition just using Atlas and doing a cohort definition using Criteria2Query. But we are going to be randomizing you into groups to determine which study you do first and which tool you use first. And this is just going to help us with being able to measure how well you guys are doing at this particular task. So Colin, is there something you wanted to show?
No. So the trials we are going to do, we provide 2 trials here, TACOS and DCP.
Oh,
so
your mic's not on now.
Okay.
So I will distribute this, team tags. Basically, each task is going to form a team. Is that okay? Each task is going to form a team.
So you guys are in rows that happen to have 2 desks. So we're going to be basically like splitting you. And those of you who are like straddling your legs between the arms, we're going to make you move over one. So basically, like, we're going to be splitting you kind of like halfway through the table. And you guys are each going to be groups. We're going to now randomize you. So you're actually receiving from Kong's actually to hand you. And what you're going to see on this is, and we're going to explain it in depth, but basically what your randomization key is doing right now is actually telling you which of the 2 studies you're going to start with and which of the 2 tools you're going to start with. This exercise, you're actually going to see that there's going to be probably about a half dozen of us wandering around the room at all times. We are all here to help you with using the tools. And so if you have any questions, don't hesitate to raise your hand. The other thing that our students at Columbia are going to be doing is we're going to be measuring your performance. So if you see them with do you guys actually have like watches or something like that? Oh, like an actual watch. Okay, old school. Nice, Jimmy. So we're going to be actually writing down things, just so you know. We're not judging you or anything like that. I mean, I am judging you, but they're not judging you. What we're actually doing is we're actually trying to keep track of how long this task actually takes for you to do, because we're trying to understand this question of efficiency, of like how long the task goes, as well as quality. So we're going to be looking at the accuracy of what happens when you say you're done. And so the specific activity that we're going to be doing, you're going to be doing 2 studies, but what we're going to be asking for you to do is to be keeping track of when do you start the first study and how long it actually takes for you to be done. When you're done, we'll actually keep track of when you start the second study and how long it takes until you're done on that side. Yep, question? What's that? If you type that, if you type in that, okay, so we'll, so we're going to get, okay. Is that link not working? Yeah, we didn't send the link.
checkpoints.
Yeah, did you get it all out? Okay. So go ahead and start explaining.
So all the teams get the team tags, right? So one thing I would like to mention is every team should report in each checkpoint. Basically, whenever you start an exercise, just tell your TA to know about this. So we have TAs here, so come here, all the TAs, and tell your TAs you start the exercise. And whenever you finish the exercise, you let TA knows. So basically, you have 2 exercises. Start one, report a time, and you end one, report a time. Also, there's another 2 checkpoints for criteria query specifically. If you look at this instruction for exercise, okay. Okay, so if you read this, there are 6 checkpoints. Okay, so for Atlas, there are 2 checkpoints. When you start Atlas exercise, you are going to write down the time. And for checkpoint 2, you are going to write down the time. Make sure you do save your cohort, okay? And ask your TA to make sure you do save your cohorts on Atlas correctly. Follow certain name convention. Just spend a few minutes, read this, instruction for exercises. Is that okay?
Yeah, can you pull that up?
Yeah.
All right, so I know everybody's eager to get started. We want to make sure that everybody understands the rules of this experiment just to help us with getting this down. So if you just give us 1 more minute for Kong to go through this for you.
So there are 6 checkpoints, okay? So for Atlas, there are 2 checkpoints. When you start this exercise, write down the time and let your TA know you start your exercise. For checkpoint 2 is when you finish your cohort definition and you do save your cohort definition in a certain name convention, which I mentioned in this instruction paper. Basically, it's team 01 or team 02 based on your team number, and Atlas-F. So follow this instruction in checkpoint 1. And for criteria query, there are 4 checkpoints. So for the first one, when you start the exercise, let your TA know when you start your exercise. And for the checkpoint 4, basically, is when you initially load your criteria query generated criteria to Atlas. So basically, there's a button check on Atlas. Once you load that, those cohort generated directly by Atlas, by criteria query, you are going to report this, tell your TA, and make sure you name it, follow certain name convention, which I mentioned here in the instruction sheet. It should be team, if you are team number 1, just team 01 C2Q-I, which means this is a cohort initially generated by criteria query. And for checkpoint 5, we want to save the cohort generated by criteria query, and you are going to create your criteria query, your cohort definition based on the cohort generated directly by criteria query. So checkpoint 4, basically you copy the initial cohort and create your own cohort, working cohort. You are going to work on this template, and then you also name it. Then finally, once you finish this exercise, just let your TA know and save this cohort definition, follow the name convention, team 01 C2Q-F. Is that clear? I see a lot of confusion in everyone's face.
So here's how we're doing the exercise, guys. You need to read the handout in front of you as a team. When you read that handout and make sure that you understand it, do not start the exercise until you've read the handout and you understand it. When you've read the handout and you understand it, I want you to raise your hand. One of the TAs is going to come over and confirm that you understand the handout.
Okay,
At that point, we will let you start the exercise. Okay? You do not get to start until you've raised your hand and someone can agree that you've read the handout.
Okay? More handouts.
So if you've read the handout and you're ready, raise your hand and a TA is going to come over. Does the handout have the ct.gov links in it?
Oh, no. Yeah, no.
One additional piece of information, the 2 trials you're doing, the NCT numbers are on the agenda. They're written on the bottom of the agenda. So if you just go to clinicaltrials.gov, you can type in those numbers to get to the starting point.
So a very general question. If you cannot find some concept set you want, just ignore this. We're not going to create a concept set if you cannot find it. Okay? So we try to pre-populate all the concept set we can think of it. But if there's something you think, okay, there should be some concept set, you don't find it, just ignore it.